Welcome to the DAMG 6210 project presentation for summer 2023. Team 1, are you ready to go?
Yes, Professor.
Great, it's all yours. Go ahead, please.
Hi, everybody. Hi, Professor. So the topic that we've chosen for our database is sports league management. And to start with, today we will be I'll take you through the main contents of our PPT today. So we are going to be discussing how our database document has been designed, our ERD, all the triggers and functions that we've used, our SQL views and visualizations, and all the reports that we've included. So to start with, what is the main purpose of a sports league database? So we all know, we've all been watching sports. So you know how difficult it gets with all the data, the number of players that are included, how they're performing, if they're injured or not, they're willing to play or not playing, have they retired, their age, everything is a lot. So in order to manage all of these and keep track of everything, we have come up with a solution, which will be this database management. So it'll statistically track all the features and it'll help us make better decisions and have a proper successful sports league. So the main problem statements that we are covering is inefficient player registration, disorganized team management, lack of player performances, the statistical insights, and all the communication gaps that are there between the players, their families, the teams, and lack of data-driven decision making. So coming to the business rules, there are multiple business rules. Each player will have a unique ID and attribute, their name, date of birth, height, weight, and age. Players will have relationship with their profiles, teams, rosters, contracts, their statistics, and their injuries. The player profiles will be in a position, they'll have jersey numbers, and their experience level will be shown. Player team relationships, their how they are linked, how the player and the teams are linked, that will be shown over time. Teams will have relationship with there'll be a player team relationship, there'll be a coach relationship with the contracts, with the win or loss table to maintain if the team has won or lost and how their statistics are going. All the coach IDs will be unique and each team will have one coach, and all of their personal details will also be mentioned. Games will have unique IDs so that we can keep track of the win and loss tables. Games will have relationship with the results and the rosters. Rosters will link games, teams, and the players. Contracts will have unique IDs. When a new player is being drafted into a team, we can see their start dates, end dates, and how their salary, how much they're being paid in each time they're done. Game stats and unique IDs will be there. Players and game references will be shown. There'll be assist blocks, steals, rebounds, all these will be shown. So these are multiple business rules that we have. So going further into how the database works, I would ask Pramit to take over from here.
Yeah, hi everyone, I'm Pramit. So these are the entities in our database. So let's start with team. So every team has multiple players, which is another entity. It can have more than one coach, and the team and the coach are linked through team coaching. The team and players are linked through player team. We have player contact, which keeps track of the contacts offered by every team to its players. We have injury history, which is a list of the injuries that players have encountered. We have game, which keeps track of the games both in the past as well as the future. So every team has multiple games. We have the win-loss table, so that keeps track of the wins and losses for every team. We have game stats, which are performance-related metrics for every game. And we have season stats, which is a historical data of every player's performance statistics. We have team roster, which links every game to the teams that are taking part in the game and the associated players. So I think that I've covered the entities. We can move on to the next slide. Yeah, so this is our ERD. So I'll just briefly explain how the entities are linked. So we have the team entity. The team entity is linked to team coaching, which is again linked to the coach. So every team can have one or more coaches. So that's why the many relationship on the team coaching side. We have the win/loss table for every team, which keeps track of the win count and the lose count historically. We have player contract, which stores the contracts that are offered to the players. This is again one to many. We have player team, which links the players and the teams. We have season stats, which keeps track of every player's statistics like points per game, assists per game, etc. We have the injury history, which keeps historical track of the injuries for every player. So a player may or may not have an injury, so it's optional on that side. We have team roster, which links team ID, player ID, and game ID. And we have game stats, which is linked to game. The game stats are similar to season stats. It stores similar metrics, but it's based on a particular game. I think that covers the overall picture of the ERD. So I'll like to pass it on. The next slide.
Thanks, Pramit. Good afternoon, everyone. So we have triggers. So triggers are basically the event-driven actions that responds to a specific events or an actions that allows us to implement custom logic and behavior in our project. So we have covered majorly 4 types of triggers. So first one is the win or loss update trigger. This is fire when after an insert or update operation on the game table. Next we have is the update on the injury status. Is basically fire after an insert operation on the injury table. So basically it will update the status of a player who has an injury in the past. In the same time, we have the update injury status on the lead. So this trigger is basically fire when an delete operation occurs on the history table. And the last one, we have a trigger that auto calculates the statistics. So it is basically fire when the insert operation occurs on the game stats table, and it will calculate and update the seasonal statistics of a player using the computed statistics from the function that we have compute player stats. Next we have is the table level constraints. So a table level constraints are the declarative rules that define the data integrity requirements, which ensures that only valid data are stored in the database. So we have like a couple of table level constraints in our data in our project. Majorly we have covered coach that checks the experience level between the different coaches of the teams. At the same time, we have contract and contract dates between the player, so on. And in the same time, we have team roster, which checks the unique constraint of the player team. Next, we have is views that will be covered by Ming. Over to Ming, you.
Okay, hi everyone. This big view is about players, including the team information, game point information, contract information, and injury information. The first small view is the view on the top 5 player on blocks per game. The highest blocks per game is 2 points. The second view is the top 5 player on assists per game with the largest number of assists, with the largest number of assists per game being 8. The third view is the top 5 player on the point per game with the highest point per game is 25. The fourth view is the players on the steal per game with the highest steal per game 4. The fifth view is the top 5 player on rebounds per game with the highest rebounds per game 11. Okay, you can turn on the next. And for the visualization part, the first graph is a pie chart about players' weight, with the largest proportion being 80 to 89 kilogram at 35%. The second graph is a pie chart about players' height, with the highest proportion in the 185 centimeter or taller range. The third graph is scatter plots of player age and height. For the fourth graph is a bar chart of player experience with the most common distribution being 5. The fifth graph is a pie chart of player age with the highest proportion in the 24 to 29 age range. The last image is a comparison of players based on game point. The points per game range from 12 to 25. There are relatively few blocks ranging from 0 to 2. However, there are more reborns ranging from 5 to 11. Okay.
Uh, Thank you, Meng. I will be running through the code real quick. Let me know if you can see the screen, just so if someone can confirm, that would be great.
Yes, we can see the screen.
Yeah.
Okay, thank you. So yeah, this is the code which we wrote for our database. So we're creating the database here. So all these statements are to create the tables of the database. That's coach, team coaching, player. So we have 12 entities in total, and we have constraints added, some in the table and some separately, because we had to add constraint later. And these are the table level constraints which are based on a function. So this is the top three you can see: checkpoints, check assists, check steals, check blocks, check rebounds. All this is to make sure that none of the values are negative. And and this function right here, the create check player on team function, what this does is that it checks whether the player is on a particular team before being rostered, so that we don't have any duplicate values or non-correlated values. So if player one is a part of team one, this makes sure that player one doesn't get rostered on team two's roster. So yeah, that is pretty much it. And these are some more constraints we added into the database. It's just making sure that the values are positive. It's basic constraints. And here you can see that the contract start date should be before the contract end date. And we are making sure that the home team ID and the away team ID are different. And these are some null checks which we incorporated. And the injury date is this particular constraints make sure that the injury takes place in the past and not on a future date. Yeah, all the other constraints are pretty self-explanatory. This, yep. Yep. So this is some sample data we added. This is the coach data. This is the team data. So it's loads of data which we added. I'll scroll here for you to have a look. Yeah, this is the player data. We have like 30 players in the database right now, just for sample purposes. This is the contract data, injury history data, game data, win-loss, table data. So this is the data. I'll just run through this. Yeah, so these are the functions and procedures. So which team wins to determine on basis of score, update win team. So on basis of the win team ID, the win-loss table will be updated. So this is, and then let's move on to the triggers. Triggers is like win-loss update. Same thing is getting updated. If we insert game result, then the win-loss table will be updated. Update injury status as Gil went over. It will get updated when a player is inserted into injury history table, on delete, the injury history will say no, and this is to auto calculate stats. And this is the code for the views which Ming explained. Yep, that's pretty much it. We could have built a lot. We have a scope of building a lot on it, but this is like the most functional we could come up with. And we are open for questions now. Thank you.
Hi, team one. I had one question.
Yeah.
So you guys have the functionality that the players can change the team.
We didn't add any functionality specifically to change the team, but what we can do is we can just alter the data in the table, and we added a constraint where check player on team is there. So if we switch that, if that function will essentially act as the functionality which you're talking about. So if you manually change the data, we can. There is a scope of adding this function which we didn't, because this is the basic functionality which we discovered and implemented. But the check player on team essentially works in the same way.
Okay, thank you.
Hi, I have one question about
Yep.
the URD design. Here I have you have three entities which are called teams, player, contract, and the player. According to graph, teams have a one-to-many relationship to the player contract, and player have a one-to-many relationship to the player contract. So do you mean that each team can have multiple contracts and one player can have multiple contracts? So I'm wondering why you set up the contract entity. What's it aim for? What it aim for?
Pramit, would you like to take over for this?
Yeah, sure. So I think contracts can get expired. Like in the previous question, it was mentioned, so players can switch teams. So the old contracts can also be in the table as well as the new contracts can still be there. So we just added that part for that. Hope that clears it.
And also, if we
Yeah.
mix player contract and player table, we'll have a scope of having null columns in the
Right.
database. So there can be players who are not under contract but are registered in the database, like players before they join the league, or players after they leave the league. So they can have null data column. So to avoid that, we separated the table to maintain data integrity.
Okay, get it. Thank you.
If there are any more questions, we're ready to take them. Otherwise, I think we're up.
Great work and the presentation from Team One. Your reporting and the visualizations were great, and the Q&A session was great. Thank you all.
Thank you, Professor.
Thank you,
Sure.
Professor.
Thank you.
Let's welcome Team Two.
Hello everyone, we're just setting up the screen. Just a few seconds.
There we go.
Hello everyone. Good morning to the West Coast people and good afternoon here on the East Coast. I'm Hinal from Group 2 and they have built a database for Sportsbuster Center Management, which is kind of like a fitness club management. We came up with this topic because like fitness was like an integral part of all of our group members, and we came to a conclusion that this would be a good topic as many of the people currently are very intrigued about trying out different workouts in the gym and the fitness clubs. So we thought of going with this one, and yeah, next slide, please. So the contents for this presentation, we are going to go over are the purpose for our database, the business problems that we addressed, the business tools, the requirements for the design, the final ERD, the implementation of the database, which all with all the features that were necessary, and finally the reports and visualizations. Next, please. Okay, as I mentioned, the purpose of our database was to build a more streamlined operation for a fitness center because number of people registering for fitness clubs is increasing and it can get difficult with like a normal database. So having more streamlined operations definitely helps a lot. So the purpose is for more effectively managing a fitness center. If we could have a centralized platform for different organization analysis of a lot more than just working out, but different fitness classes, paying the fees, and lockers as well. So that was the purpose. And the different business tools that we have taken care of are every employee should have a unique employee ID. Every member has should have a unique member ID, a unique class ID. Also, the attendance is again very important. So it should at least link to a class, a specific class. All the equipment IDs should be maintained and we have to take reports of this as well. It is also important to look after the equipments. So a unique equipment ID for all the equipments, also maintenance record for this that specific equipment ID. Payments again is very important. So it should link to a member. Next, our locker assignments should be unique and no contradiction with one locker at a time as well. And each member also should be able to register more than one fitness class. No concerns over there. And of course, the certifications are important for the employees because they should have proper certifications if they're going to train so many people. So that is about the business rules. Next, please. So the business problems that we've addressed is a more effective membership tracking and the renewal management. It should be the renewal process should be smooth. The classes scheduling should also be optimized based on the attendance and better class offerings and take feedbacks as well whenever required. More effective tracking of the equipment and its maintenance, tracking of membership fees, their payments, their dues, their financial reporting, how was their progress over the week or over a month, then different coordination amongst the staff and certifications, and of course the customizable reports based on the demographics of every. The demographics are different for every person joining the gym, so their attendance, their revenues, and so that would help us in data-driven decision making and performance analysis. Next, I would hand out to Namrata, please.
Yeah, coming to the design requirements, the cross foot notation is utilized with clearly indicated with the primary keys fields and foreign key, which is noted as PK and FK. Each establish relationships between tables by drawing lines that directly connect the fields involved in the relationship. And the notation is used 0 to many, 1 to many. And you use a cross feet symbol next to the field where the line terminates to indicate the table on the many sides of the relationship. Coming to the ERD diagram next. So this is our ERD diagram with the 12 entities, and each entity has its own attributes. Each, as Hinal explained the business rules, each member has its own unique ID and profile. Even each profile membership profiles also have its own attributes. I'm sorry, its own ID. So coming to the member profiles, it directly is one to many memberships, and the member profiles have access to the locker, and the
member profiles I have one too many with the payment too. The member profiles, whoever take the memberships can have the class attendance and class attendance. And about this calendar dim is that it will contain its date and date of week with access to the all the members memberships and locker too. And the staff profiles has one to many two certifications, and the certifications has one to many two class types, which has its name and display certifications ID. And the class type has one to many two fitness classes. That's it. Over to Shubham.
Hey everyone. So on this slide, we're going to be talking about the database implementation. So we created a database that was called Group 2 Final that pretty much stores all the fitness center related information. And we have one function that is called get full name that pretty much takes the member ID as an input and then returns the full name of the member by pretty much concatenating the first name and last name from the member profiles table. And then we have like several tables that are related to fitness center, such as member profiles, memberships, payments, lockers, staff profiles, certifications, class types, etc. And then we have various insert statements that are for the designated tables. And like I was talking about the function for the get full name. So we created the function before we created the table for the member profiles. And then we have some constraints that ensure data integrity and validation. And for example, we have a check constraint to the locker table to ensure that the rental date is always greater than the rental start date. Also, we have another one for the member profiles table that checks to see the membership type allows only these specific values. For the gym member, it could be premium, basic, or standard. And we have two views for the database reporting views. That's for the class attendance report and the staff certifications view. Next slide, please. So this is pretty much like a snippet of the creation of all the tables that we have right here. And can we go to the next slide, please? So this is like a snippet, like I was saying earlier, about one of the computer columns that will return the full name that is based on the member ID from the member profiles table. And from here is where we return the full name by putting in the member's first name and last name. And we check the member ID that's based on the input of that. And I'll hand it over to Mark to talk about the next slide.
Thanks, Subham. So I'm just going to talk through the code for a couple of the components that Subham just outlined. So first, the table level constraints. So you can see we've created one for the lockers, just to validate that the dates that are being entered for the rental make sense, that the end date is after the start date. And then we've added one for the membership profiles to make sure that the membership that's entered is one of the types that we allow. So that just helps keep the data consistent. And if we could go to the next slide, I just want to speak about our reporting views. And really the intent here is just to take some of the different data sets that are very commonly going to be used together and connect them. So we've created a class attendance report view that combines some information from the member profile with the class attendance as well as with the classes, so that you can identify who's attending a class without having to write the join code in your individual query. And then we've done the same thing for the staff and certification. So this allows us to get an overall view of all of the staff members at the fitness center, their job title, and the certifications that they hold, so that we can see in one place, how many members we have who are certified to teach a certain type of class, and so on. And then we'll turn it over to Ane to speak about how we've actually implemented some reporting around this.
Thank you, Mark. So hello, everyone. I'll be going over the visualization part that we have created for the views. I hope I'm audible.
Yeah.
Yes.
All right. So for the visualization part, for the two views that Mark spoke about, we have created it using the using Tableau. Let me go over Tableau real quick. So this is the first sheet. Along the rows, we have the months and we have the count of member ID in the columns. So we can get the count of participation of the clients in different classes. we have made use of this mark section to denote different colors for the count of members that were present or those were absent for the classes. This is basically for getting the insight of customer participation in different classes, so that the gym administration would conduct different activities so as to boost the participation of clients in different activities. The second one which we have here is the certification, employee certification details to get a count of different employees that are serving different roles. So as we can see, we have 2 fitness instructors, 2 gym managers, etc. So that the gym administration could keep a count of it and hire more employees for different roles whenever they are short of employees. So this was about the visualization, and this is the dashboard where we have incorporated both our views. That was about our visualization part. So we are open for any questions if anyone has. Let me go over the code once. This is the code for our database implementation. I would like if Shubham goes over this.
Yeah, so as and I was sharing, though, this is like pretty much one of the computer columns that we created where we return the full name, where we put the member ID, that's the input, and then we return the full name by passing them first name and last name from the member profiles table. And then we refer to that function when we create the member profiles table. And then can you keep scrolling down, please? Yeah, keep going down. So these are all the other tables. These are various insert statements for all the tables that we have here. And can you keep scrolling down, please? Yep, keep going down. It's all dummy data that we have for each of the tables. And then lastly, here are the constraints that we added. And here is the database reporting view that we have for the class attendance report, as well as staff certification view. And yeah, we'll now leave it for questions and answers right now. Any questions, answers?
Yeah, so I had a question. So in your memberships entity, do you have any way to keep track of like how long the memberships are valid for?
So we put in, at the moment, we have the date that they joined, so we know when they've started the membership, and then we're tracking their status. So we have whether the membership is active or not, what the status field is for.
Okay, so as long as they pay for it, it's active. That's how it works, right?
Exactly, yeah. So if it was a value with a type and the status is active, then they would still be an active member. If not, it would be expired, and that would let us, target them for potentially sending offers to try and get them to renew their membership or something like that.
Got it. Yeah, that clears it.
Any other question or comments for team 2?
Also, like every member profile can have multiple memberships associated with it, right? Like, so how does that work?
So it's possible that they could have different different memberships active, or maybe if we offered some type of premium subscription or things like that. So we wanted to put provision in for that. That maybe you have a base membership with the gym, but we sell a subscription to sign up for certain classes. We'd be able to add those kind of add-ons in the future. So that's why it's allowed.
Okay. Yeah, that's all from our side.
Yeah, going off what Mark said, that goes back to the constraint that we have where we had a constraint for the membership type. Your question that you asked.
No further questions from my side.
Thank
Great.
you.
Yeah, thank you for the great work and the presentation from Team 2, and thank you for the questions. Let's welcome
Great
Team.
question. Mhm.
Thank you, Professor.
Excellent, great. Let's welcome Team 3.
Thank you, Professor.
Sure.
Hi, everyone. I'll just share my screen. Can you see my screen?
Yeah, you are on.
All right.
Yep. Okay, let me get started. Hello, everybody. This is Team 3, and welcome to today's presentation. Our topic is about a flight ticket booking system. And through this presentation, we're going to see the business problems addressed by our database, the design and implementation for the database with all the computed columns and check constraints. And last, we will see what kind of insights that we can extract with the help of visualization tools. So now let's get started. Next, please. Okay, first let's meet our amazing team members. We have Tianzhi Forum and me, Shige, and also Xiaolong. Next. So I think most of us have had experience buying a flight ticket, either through the airline website or some other websites. And those are all consumer-oriented platforms. So what's different about our database is that it is designed for a B2B platform. So it will be used to maintain the data for flight bookings and cancellations, evaluate sales performance, track transaction details with its business partners, and also extract analytics to improve the performance for the system. So the business problems addressed by this database will be including setting proper sales objectives by analyzing the data. And second, we can track the revenue by partners to monitor the effectiveness of our business partnerships and identify any opportunities for collaboration and growth. Third, we can look at sales by geography data to optimize our strategies for business development and also for marketing. And last, we can use the data to track revenue growth or job and maintain an overall financial health for the platform. Next. Before we dive deeply into the database, we just want to give some more introduction about where our platform is placed within the industry, so that we can all have a better understanding on what the database is about. So like I said, this platform is a B2B platform, which means we won't be directly interacting with the passengers. Instead, our suppliers and buyers on this platform will all be business entities, which include like traditional travel agencies or online travel agencies and tour operators and also corporate travel agencies, etc. So as the platform, we will be aggregating information like ticket pricing and availability from lots and lots of suppliers so that everybody can come and search and buy tickets on this one platform. And this way we facilitate the ticket sales within the aviation industry. Next, we will have Shalom taking us to see the ERD design of our database.
Thank you, Emily. So next, let's talk about the ER diagram, which we use to navigate through our entire system. We have normalized our system to a 3NF to avoid any repeating groups, composite attributes, and any many-to-many relationships. We have 12 entities created, and each of them have their respective attributes. And we have labeled primary keys and foreign keys as PKs and FKs. Most of our entities here have a non-identifying relationship, except for PCC and partner entities, where they have an identifying relationship. And all the entities in our tables have a strong entity. To emphasize a little bit more on the PCC entity, so PCC stands for pseudo-city code, and it is essentially an identifier that differentiates our suppliers. Now, a supplier itself has a PCC, and one supplier can have one or many PCC accounts, which is why it has a one-to-many relationship. And the PCC code directly affects the ticket price for a flight. Moving next, we have the business rules. We have incorporated all these rules into our system, and most of which you will see in the form of views, table level checks, functions, and visualizations in the upcoming slides. To emphasize on the first business rule, if we consider an order, each order by default has two transactions. The first transaction is from the buyer side, and the second transaction is from the supplier side. The difference between these two transactions is essentially our profit, and we calculate the total revenue based on this profit for each order. Next, we have the tables. We have used a general SQL script to create the tables, where we specify the table name, the primary key, the foreign key, and any constraints wherever necessary. Moving forward, Tanzi will take over.
Thanks, Shalom. After creating the tables, let's move on to the data insertion. Here are some examples. The provided codes here are the SQL insert statements that insert multiple rows of data into the flight, orders, and order transaction tables. Next, here are some examples of how we generate views. The sales by supplier view will display the top 10 suppliers based on their number of orders in descending order. The sales by buyer view will display the top 10 buyers based on their number of orders in descending order. And the most visited place view will display the most popular destination places based on sales amount and the number of tickets sold. And my teammate will show the report later. Next. This is how we implement the computed function to add a new computed column called profit to the orders table. It takes two parameters, buyer amount and supplier amount, both of data type money. It will return the computed profit, which is the difference between the buyer amount and supplier amount, also of data type money. Next, here is the result. You can see the computed column profit will automatically calculate the profit for each row in the orders table based on the values of buyer amount and supplier amount for that row. Next. Here is how we implement the chair constraint function for the order transaction table. The chair constraint enforces that for each order ID, there are no more than two corresponding transactions with specific pay types in and out. If any new row violates this condition, the insert and update operation will be rejected. Next. We can see here, for order ID 12, already contains two transactions in and out. If we try to insert another transaction for order ID 12, it should fail due to the check constraint. Next, Forum will present the reports.
Thank you, Tansy. Embarking on a visual journey across continents, we see a captivating geographical visualization depicting the most visited countries. This vibrant map showcases sales intensity through color depth, which means deeper colors indicate higher sales intensity, allowing us to quickly identify countries with significant revenue contributions. As we see,
We're doing pretty good in the US, Brazil, and Australia. The second image is a visual representation of the most popular customer itineraries. We've shown the top 10 itineraries that are most frequented routes and destinations, providing a snapshot of our customer travel choices. So these insights basically guide us making our marketing efforts and promotional campaigns for the most alluring destinations and help us craft personalized packages and promotions that align with our customer expectations. The next slide, please. Here we present a compelling visualization that sheds light on two crucial aspects of our business: sales by buyer and sales by supplier. These visualizations basically provide a comprehensive view of our revenue streams, allowing us to make informed decisions and cultivate fruitful partnerships. So by analyzing sales by buyer, we gain a deeper understanding of our top performing customers and their contribution to our overall sales. And if you see, the sales by suppliers enable us to assess the effectiveness of our partnerships and negotiate favorable terms with our suppliers based on data-backed performance. The next image on this slide is basically transitioning us to see that we present an insightful line chart, which depicts revenue by the week. So this visualization offers a dynamic representation of a business revenue trend, showcasing both the order count as well as the profit in USD over time. So the peaks and valleys here indicate insights into demand patterns and potential operational challenges. So this insight basically helps us gauge the effectiveness of our revenue generation strategies. In the next slide, we see some of the key highlights and key improvements in our database. So by promoting a B2B business, we are facilitating sales in the aviation industry. For targeting marketing strategies, we are analyzing popular flight itineraries that allow us to optimize marketing efforts and promotions. And we can tailor our campaigns that will resonate better with our customers, boosting engagement and conversions. And as Tianzi explained, we've implemented check constraint to enforce data integrity. Some key improvements would include incorporating more data for comprehensive insights into revenue trends and sales. We could have added more check functions. To give an example, automation of processes such as auto cancellation of orders after a particular time limit, say 30 minutes, for incomplete payments. And more details for financial accuracy. So currently the order transaction table is the only data table where finance is involved, and we can add more tables for financial data. These enhancements underscore our commitment to refining operations, nurturing partnerships, and achieving excellence. Thank you, and we are open to any questions that you might have for us.
Yeah, I have a quick question. So regarding the function that you guys created, what if in the off chance that the supplier amount is greater than the buyer amount? Is there a check for that in the off chance that ever happens? Or is the buyer amount always greater than the supplier amount?
Thank you for the question. I can take this one.
Sure.
So in our sample data, there are dummy data that we inserted into the database. And currently we don't have a minus profit, but in reality, there can be this possibility. So the supplier amount can be, higher than the buyer amount. That would be because sometimes if the platform is doing some promotions like incentives, it will maybe lower the price and just to incent the buyers to buy more tickets from us. So yeah, that would be a possibility.
Will this affect the visualization if it's a negative profit value or?
Yeah, definitely. If it has an order status of confirmed, yes.
Oh, but what about pending?
Pendings are not currently calculated into the total profit.
Okay, got it.
So we're only seeing the confirmed orders for the profit that we're seeing.
Okay, no, thank you. Makes sense.
Thank you for the question.
Yeah, sure.
Any more questions? All right, I think we're good to go.
Excellent work and
you.
presentation from Team 3. Your slides were great, and the data analysis was also great, and great question. Thank you.
Thank you.
Thank you
Professor.
all. Sure. Let's welcome Team 4.
Yes, Professor. Share my screen. Hello, everyone. Is my screen visible?
Yeah, you are on.
Yeah. Okay. So hello, everyone, and good afternoon, Professor. Today, we are going to discuss about our topic, which is logistic management system, presented by me, Abhinav, Anutej, Rohan, and Zil. So after doing a lot of brainstorming sessions and by putting a lot of efforts, we have decided to like choose topic on logistic management system because logistic is the backbone of every country, as well as like if logistic is broken, then people will suffer due to their orders and requirements. So today I want to shed the light on the remarkable transformation that the world of logistics has undergone, driven by the trade expansion and transportation advancement and the power of information technology. So the logistic landscape now thrives on digital platforms and harness on magical automation, such as data analytics, information technology, and expedite the process of the technology. And now we are in the era of e-commerce, which is like soaring demands for the swift and reliable deliveries. So in conclusion, the rapid evolution of logistic management from manual coordination of tech-driven symphony has been like chapter in the business world. So now like we need the logistic management system, plus we need the technology to embark on the journey that the tasks we need to perform. So I'll go to the next slide. Yeah. So our objective, business challenges and business rule. Like throughout this presentation, we gonna go through the database implementation, ERD, triggers, functions, and the visualization that has been designed. So our objective, our objective was to design a logistic operation and simultaneously track orders and tasks for the logistic management system. And the business challenge, like the challenges we overcome through this project is that we have designed a comprehensive database for the logistic management agency and aimed at optimizing the streamlining logistic operation. The system aims to centralize and manage data associated with the transportation, warehouse management, packaging, and order tracking. By consolidating this information, it empowers the agency to meet client requirements with customization and efficient delivery. So for ERD, I'll hand over to Rohan.
Hello. As previously told by Sachin, our objective is clear. It's to create a logistics management system to seamlessly track orders, tasks, shipments while efficiently handling our resources and meeting client demands. So some of our focus points are the comprehensive tracking using multiple tracking points and real-time updates, centralized operations by consolidating transportation, warehouse, packaging, tracking data to enhance decision making, structured collaboration by having our employees aligned with specific departments, and we have also integrated financial records to provide a comprehensive understanding of our agency's metric. I'll just introduce the main entities of our model. My teammates will be providing the detailed insights. So the nucleus at the center is the logistics system. We'll be using that for managing requests, shipments, departments, as well as all the connecting operations. The shipments entity is the backbone for tracking, packaging, transactions, as well as warehouse routing.
And employees will be our main resource, driving collaboration and linking personal. We link personnel to respective departments for streamlined operations. Transactions and finances are also captured, and we have customers and reviews to enhance our services iteratively. There is the transportation mode and the packaging entity to optimize shipments by reduce delays and damages. And we have the warehouse and shipment warehouse to manage the physical aspects of our logistics system, optimizing storage and operations. Now I'll give a brief overview of the flow. Next. Next slide. Oh. Yeah. So this starts with the customer browsing our catalog and then placing an order. The system creates a new transaction record and the associated tracking ID. The system then processes the order. It determines the best transportation mode and packaging details based on the characteristics of the shipment. Shipment tracking and transport is next. The tracking ID is assigned and warehouse routing is finalized. All the details are then committed in our system. The tracking details are also shared with the customer at this point. Now the shipment reaches its destination warehouse following via the mapped route, and it then gets delivered to the customer. On shipment delivery, the system updates the delivery confirmation transaction as well as the financial records. And at the end, we offer optional customer feedback, which will be recorded in the customer reviews entity. Jill will now proceed to explain our database in more detail.
Yeah, as Rohan mentioned, that logistic system is the heart of our logistic system table. It's a heart of our logistic management system. It consists of all the crucial tables, foreign keys, the table, and we have created all of the tables which are used in our ERD also. All of them we have created, and we have given the primary keys of all of them. We have also given the next slide. Yeah, so we have created the foreign keys for all the tables, which is consisting of which references to its primary key tables. Also, we have given check constraint for employees, and where we have a zip code, and also we have given check constraint for the company table where we have a phone number which cannot be greater than 10 in numbers. And also we have given the list of warehouse states which are all included in our which are all included in our insert statements also. Next, let me go through the functions used in our logistic management system. The first one is the calculate age from the date of birth. So we'll for each employee, we have given the date of birth. So we'll calculate the age based on the date of birth. So it also helps automatically to determine the age of an employee, and we are updating the column age in it. Then we are calculating the average rating for the customer reviews. The customer, it calculates the average rating given by the customers for a particular shipment. Like by aggregating all those customer reviews, we are giving the average rating, and we are also calculating the volume occupied by the warehouse. Like this function calculates the volume occupied based on its volume and the available quantity. It helps us to determine the space utilized by shipments in a particular warehouse, like aiding in the efficient warehouse management. Next, Abhinav will go through the views and encryption.
Hello, everyone. So let's start with the encryption. So for the encryption, we have used the symmetric encryption method. In this, we have first created a master key, and we have encrypted that's the password Team4 Summer 2023. Next, we have created a certificate which are used to protect sensitive data and keys within the database. This certificate will last till 31st December 2026. Next, we have created symmetric key. Symmetric key is actually used for encrypting and decrypting the data in this. And we have used the advanced encryption algorithm with 128 bits of key to encrypt this. Lastly, after creating the symmetric key, we need to open the symmetric key every time to actually use the encryption and decryption. And we have also opened the use of symmetric key for decryption here as well. So now can you move to the next slide? So we have determined that in the employees table, the password and street are some of the most sensitive data. So to encrypt that, we have created a few functions and a trigger for that. So let's go through the function first at the top left-hand corner. So debut that encrypt password. In this, we have obviously encrypted the password. If you see the lines that encrypt password is encrypted by key GUID, user encryption. This is the actual function that is doing the encryption here. Next, if you should see the right-hand side of this, we have used the same function, similar function to encrypt the street. Lastly, at the bottom left, you can see that we have created a trigger. The trigger runs every time on insert and update, and it encrypts the password and street, and then stores it back to the actual table. Lastly, towards the bottom right-hand side, we can see select star from employees. So by default in SSMS, if we use the select star command, then the encrypted column would be blank. Like you cannot see the street or password in the normal query. So if you want to actually view the data, you have to use the decrypt by key command, which is towards the bottom. Select employee ID and convert decrypt by key. You have to convert it to varchar because it returns a hexadecimal type format. It is not desirable in our case. Now let's move on to the views. Next. So we have created several views for this. The first one is between employees and departments. This is very beneficial as it provides convenient way to retrieve employee details along with their associated departments. Later, when we go through the reports, then you will see there is a report between this same view. Also, like if in this view, if you can see the street column, it's appearing as blank. It is not actually blank, as I said mentioned earlier. It is an encrypted column, and it's just appearing blank. Next. Next, we have two views here, customer transaction and warehouse details. In the customer transaction, we are providing a consolidated view of customer data along with the transaction information. It makes it convenient for us to analyze customer behavior, transaction comments, ratings, and all this stuff. Next is warehouse details. In this, we have provided the most necessary warehouse information in this one key so that we don't have to repeat the same select query every time. Next. Lastly, we have the one with shipment details. This is between the shipment, packaging, and transportation mode tables. This is useful as it provides details of how the shipment is going, what is it like with the transportation method, how it is being packed, and what are the actual details of it. Now on to Anutej for reports and visualization.
Now let's look at the data visualization part of the project. As we all know, a picture represents 1,000 words. So in our scenario, a picture would represent multiple tables, data from multiple tables. Reports are generally used for generating decisions or taking up decisions from the data. We have used data from our database to take decisions to help in taking decisions like which warehouse city can be extended to hold more of the shipments. Then how is the employees divided between the departments, and what is the income or the revenue that is being generated in quarter wise. So if we take a look at the first slide, this report gives volume occupied by warehouse city. So on the x-axis we have the warehouse city, and on the y-axis we have the volume occupied total. Based on the data provided from this particular report, we can understand which particular warehouse city we can expand, or which needs investment from the business side. Moving on to the next slide. This particular type of chart is a donut graph, and this gives a percentage breakdown of the employees in different departments. So having this look at the data gives a better understanding of how the employees are distributed among the different departments, and which department might be needing the what do we call, the income or the revenue that needs to be put in. Each segment represents a particular department, and within the brackets we have the percentage that is being contributed to the total employee count. Moving on to the next slide. So this is a line graph that represents how the trend of the revenue for our dummy data is being projected from one quarter to the other. On x-axis we have the quarter, and on the y-axis we have the total sum of the revenue that is being generated from the shipments. So moving on to the next slide. That is it from our end. If we are good to take any questions.
Thanks for the presentation. So I have a quick question about the ERD design part. Yeah, so I'm just curious because now I can see that we have a one-to-one relationship with the packaging and transportation mode. So I'm just curious, is it possible that one packaging ID can be, linked to like multiple transaction mode?
No, the transaction mode will not be changing because it's pre-decided.
So is there any reasoning for this?
Oh yeah, we can update it. So assuming we are offering something like flight and by sea, it's only going to be one of those. It's so.
Yeah. Okay. Yeah. I'm just thinking it is because I'm not familiar with this industry, so don't know if this is the normal practice within the shipment industry, that one package is always transported in the same mode.
Yeah. So what you exactly you're asking, like packaging related to transaction, right? So one packaging can have
Yes.
multiple transactions. So as per our business logic, we have designed this ERD. So in our business logic, we did not consider this aspect of multiple transaction, but like for future need, we will definitely consider this. We'll go through this.
Okay.
Thank you.
Yeah. Thank you.
So if there are no questions, then we are good, Professor.
Great. Great work and the presentation from Team 4. Great Q&A. Thank you. Thank you all. Let's welcome Team 5.
Good morning, good afternoon, everyone. Thank you for joining me today. My name is Satyam Arora, and I am accompanied by my team members, that is Aishwarya, Gauri, Shivani, and Sonal. We are excited to present to you our latest project, that is Sky Reserve Airline Reservation Management System. The contents of our presentation are as follows. So it comprises of 6 items. First one being purpose, second, business problem solved, third is business rules, fourth is ERD, fifth is database implementation, and sixth is reporting and visualization. Moving on to the next slide. The primary objective behind developing the airline reservation management system was to establish a highly efficient and centralized platform that automates and simplifies the management of airline reservations, ticketing, and associated operations. The system is designed to elevate the booking experience for customers, maximize seat utilization, enhance data management, and enable seamless fare management. Moving on, we have focused on solving the following business problems. First one being student focused benefits. The system aims to prioritize affordability, accessibility, and benefits tailored to students, ensuring they have access to cost effective travel options. Second point is pricing and fare management. The system helps airlines manage fares, discounts, promotional offers effectively to attract customers while ensuring profitability. Third point is paperless booking process. The system addresses the challenge of manual reservation processes, eliminating the need for physical ticketing and reducing the dependency on paper-based systems. Moving on to the fourth point, that is efficient flight management. The system does optimize the reservation process and enables efficient management of flight details, passenger information, and reservations. And the last and the most important being customer satisfaction. The system contributes to customer satisfaction by providing a user-friendly interface, reliable information, and seamless reservation with booking processes. For the next slides, Sonal, you're up.
Thank you, Satyam. So these are the business rules we have implemented for our data relationships and accuracy for the project topic which we have selected. So as one of our solved business problem, address business problem focuses on student, which is student can be a part of only one student group booking and also can have one or many student benefits. Also for the passenger, they can have 0 or more baggages and can give 0 or more feedbacks. For loyalty programs, we have will have one or more program benefits. So we have implemented all the business rules in our ERD and the database implementation. Next slide. Speaking of which, here is our ERD consists of all the required keys and relationship between all the entities. So we have in total 19 entities and we have followed the multiplicity notation for implementing our business rules using two components which are cardinality and participation, which status whether the relationship is optional or mandatory. Due to time constraints, we can't we can't go through all the entities in detail, but focusing more on student related information. So we have student entity, which is one-to-one relationship with student group booking and one-to-many relationship with student benefit, which satisfied a business rule stating student can be a part of only one student group booking and can have one or multiple student benefits. Also, one of the interesting part of our ERD relationship, which we discovered is we have a dual relationship between flight and airport entity. To avoid the duplicacy for the airport entity, which has two attributes, of which two attributes from the flight entity, that is departure airport and destination airport. So to avoid that duplicacy, we made sure that we are creating a dual relationship between them. Moving on. So this is an overview of our database implementation, starting off creating database, creating all the tables, then encryption and constraint. For encryption, we have used AES 128 algorithm, which will be further explained by my team members in upcoming slides. For constraints, we have implemented table level check constraint and column level check constraint. Then inserting data for all the tables. We have implemented triggers, also created functions to implement computed columns, created views, and for our data, for our data cleanup and maintaining database, we have also performed housekeeping. Moving on. So for creating table, we have created all the tables following the syntax, which is column name, data type, and also naming the primary key constraint for defining primary key on multiple columns. For foreign key stating it is referencing to which parent table of the attribute. And over here in the airport and airline table, we have implemented column level check, which will constraint, which will check the contact information and phone number digit should not be greater or smaller than 10. So further slides will be taken over by Gauri.
So for constraints, we have created function for passengers baggage weight with weight as a parameter. So while boarding a flight, baggage weight should not exceed than 50 lbs. We have also added this constraint to the bag on the baggage table. Next, we have created another constraint for passengers who are students. For these students needs to provide their student ID to avail their student benefits. We have implemented this function with student support documents as a parameter and using if-else statement. We have also added this constraint to the student benefit table. Next. Here we can see the output of the constraint. The provided values are not inserted. Thus, the constraints are successful. Next. Here we are inserting data into our tables. Further, we can see the results here of the inserted data. Further, we have created 3 views. First view is for passenger baggage tracking. In this view, we have created 2 virtual tables, temp1 and temp2, using joins. Further, to avoid duplication, we have used string aggregation function to concatenate the baggage ID and baggage tracking status columns with a comma as a separator for each passenger. This result is shown in the baggage status column towards the right side of the screen. We can see here the output for the passenger ID 100 who has baggage status 900 in transit and 901 in transit, as there are 2 baggage for this passenger. Now we can see here the pie chart report. It depicts passengers' baggage status, whether bags are in transit, delayed, hold, or damaged state. As we can see here, the highest number of bags are in transit state, which can be seen in the blue color. Next will be explained by my teammate Shivani.
Thank you, Gauri. So we have 2 more views. One is the flight details, and this view shows the important information about the flight, like departure airport, destination airport, departure time, and arrival time. The actual flight entity has airport codes as the values of departure airport and destination airport. But in order to make it more understandable, we have used other tables and joined it with the flight table to actually show the name of the airport and not the codes. And then the another view is to list the passengers who are also students. So as you can see, all the these are the passenger IDs of the passengers who are also students, and we have associated student information also shown up in the view. And let's talk about the triggers that we have implemented for our database. So we have implemented an after insert trigger, and the main function of this trigger is to populate the values under the fare attribute of our reservation table. And this value is mainly calculated based on the value of the ticket price. And we have a fixed 4% tax that is applied on the ticket price. And then we have 3 cases that we have considered. First one is that if the passenger is a student, then by default 10% discount will be applied to the initial fare. And that will be populated for that particular passenger. And second one is that if the passenger is a student and is also enrolled in a group booking, then the discount associated with that particular group booking ID will be applied to the initial fare. And for all the other passengers, we do not have any discount for now. So that is how the fare values are getting calculated. And then we have a function to generate the computed column. And this is the table travel insurance. And the insurance cost, as you can see, is the computed column for our table, and it is calculated based on the start date and end date of the insurance policy. So basically it is calculated based on the number of days that the policy number is valid for. Moving on to the encryption. So we have also implemented encryption to protect the sensitive data in our tables. And these are the steps that we followed in order to implement the encryption. And as you can see, this is how we insert the data wherein we are encrypting
the column, and we are using the system function to secure our data. The system function is encrypted by key, and here, as we can see that the values under card number are getting encrypted. Further slides will be explained by Aishwarya.
Thank you, Shivani. Can you go to the next slide? Yeah, so I will be explaining about data visualization, and first is the bar chart for understanding the number of available seats for each flight. As you can see, on x-axis are all the flight numbers and on y-axis are the available seats. Each bar here represents a specific flight and the height indicates the number of seats available on that flight. The majority of flight appears to have most available seats, where flight QF678 has the highest available seats of 400 other than the flights. Next slide. This is the visualization of loyalty program analysis. On the right side of the slide, a bar chart which is showing the total number of members in each loyalty program. The loyalty program IDs are represented by different colors, making it easy to identify them. To the left side, the same data is presented in a tabular form for a more simplified view. The analysis of these charts are giving interesting insights. Especially the travel rewards program stands out the most, highlighted in light green color, which has the highest number of people with a count of 3, whereas other loyalty programs have either 1 or 2. Next slide, please. This is the flight-wise reservation status. For this, we created a tree map which provides a detailed view of the reservation status for each flight, including its airline name. The tree map uses different colors to identify the reservation status, with confirmed status shown in the pink and pending in red color. The visualization reveals that the majority of flights have a higher number of confirmed status, while pending, cancelled, or waitlisted are the least common across all airlines. Next slide, please. This is the airport distribution by time zone. In this, each circle in the map represents an airport with its size indicating the number of airports in that specific time zone. A larger circle indicates multiple airports within a particular time zone, while a smaller circle states a single airport. For example, the circle in the USA is bigger in size as compared to Australia or Africa because it has more number of airports. Airports in the same time zone are represented by a similar color on the chart as well. Next slide. Thank you. So this is the end of our presentation and we are open for questions.
Hey, hi. So in the business rules, I saw that you mentioned there will be one or more loyalty programs. If you can go back. Yeah. Okay. Okay. Yeah. So next, if you can go to your ERD. Yeah, to next slide, ERD. Yeah. So here I can see that there is a one-to-one connection between airline and loyalty program. Shouldn't like there be one to many or something, like one airline can have multiple loyalty programs or something?
It
Can you
can, but
explain this
for,
connection?
yes, we can change it, but for now we have like for a particular airline, we just have one loyalty program to make it simpler for implementation. But that can be modified.
Okay. Okay.
And also, Abhinav, answering to your question, in business rule, we
Yeah.
have stated that a loyalty program can have one or more program benefits.
Okay, so in that case, in your loyalty program entity, there is no program benefit, or is there some other table? Okay, there is
No,
another
we
table.
have this
Yeah.
one.
Okay, yeah. Okay, I think that that's it from my side. Thank you.
Thank you for your question.
just a quick question. Considering cancellation of tickets, is there any particular
For now, we are implementing it manually so we can alter the table if we need to cancel. But that can be further implemented and we can automate it.
Any other question, comments for team 5? Excellent work and the presentation from team 5. Your
Thank you, Professor.
slides,
Thank you, Professor.
reports, and visualizations were great. And thank you for the question. By the way, team 5, I like how you have implemented the flights and the airport. Those two, the design and the implementation of those two entities was great.
Thank you,
Thank you
Professor.
all. Yeah,
Thank you.
sure. Last but not the least, let's welcome Team 6.
Hi everyone, we are team 6. Our topic is e-commerce management database design. And I'm Naisargi Thakkar and my teammates are Yunlu and Yuhang. And we go to the next slide. I'll give you the introduction, why we chose e-commerce website. Is because nowadays we have everything going online. No one is going to the stores and buying things. It's very important to have a nice database to implement a flawless e-commerce design. The main points is to have a nice and personalized experience to succeed. And for that, database is a very crucial part to manage the products, the customers, the order, payments, and other critical data. The purpose of our database is to analyze, track, and utilize the data for an informed decision-making and business growth. The key functionalities that we have is the seamless design maintenance, search capabilities, and reporting functionalities to enhance the overall efficiency and the performance of our database. Next, please. The main importance of our database is to manage the data properly, have a robust system to store and to track the data, and have seamless operations, and to have a nice user experience to give browse and search capabilities effortlessly. And also to have a proper data security of the database to avoid potential threats. And last but not the least, the personalization and targeting to use an analysis of the user data, behavior, and enabling personalized recommendations to have targeted marketing strategies and to increase sales and customer loyalty. Next. So the problems that we have addressed is to allow the business to track and manage the orders, inventories, and product availability. Also to enable business to maintain the customer information properly, to track the order history and provide a personalized experience. It also includes shipment manager information, tracking of the numbers, delivery address, and shipping dates. And also to manage the product catalog, to update the details of the product and to track the product performances. We have also added the features like wish lists, reviews, carts, shopping sessions, personalized recommendations, enhancing this to increase the customer engagement and fostering customer loyalty. Next. The business rules we have implemented is that customer can have one-to-many relationship with orders, addresses, wish lists, products, and shopping sessions. The order will have one payment, that is one-to-one relationship, but it will have one-to-many for the shipments. The address will have one-to-many relationship with shipments as well. The card will belong to only one customer, but it will have one-to-many relationship with the products. And the wish list belongs to one customer only, and it will have one-to-many relationship with the products. Next, please. The product may have one or more reviews and discounts, and it will belong to different categories and also have one-to-many relationship with the sellers and the warehouse. The discount can be applied to one or more products. A seller offer one or more products as well. The warehouse can have one or many products. Next. Johan.
Next, yeah, thanks. Next, I'm going to talk about entity relational design, which is ERD. Here you can see we have exactly 70 tables here. Most of them have one-to-many relationship. For example, here, one customer can have multiple orders, so it's a one-to-many relationship. And we have also created some associate entities to prevent the many-to-many relationship. For example, here we have created a card product connected with card and products to solve this problem, avoid this problem. And we also have many identifying objects. For example, here's a products will depends on a discount will depends on the discount product, and then depend on the products which is essentials for the structure. And next one, I'm going to talk about the implementation of the database. I'm going to talk about the database question, the computer columns, the table level check constraints, and adding some views to the structure. For the first part, this section of code is aimed for creating the database. This syntax, for example, the product ID, the category ID is all the columns names. And we also need to set up the data types. For example, here, the integer and varchar. And we also need to determine if it is a primary key or a foreign key, which is like this. So after that, we have built a table, and then we need to insert data into the table. For example, here we want to add some data points for products table, and we just typing data like this. After all, we have the following tables. I'll make it brief here. For example, a customer table, it contains the customer information. It contains the name and email. And for the orders, it contains all the dates and total amounts information. We also have an address table, which contains the address like the city, the state for all the customers, which will use this information to do some visualization thing. And for the reviews, we just record the rating and comments for all the customers' review for the specific product. There's a products table and the payment table, which contain is about the payment type or something else. And there's a discount and categories. These are all example databases we have created. Next, I'm going to so computed columns.
Yes, sure. Let me introduce the computed columns in our database. We have created two computed columns based on a function. The first one is duration column in the shopping section table. We first created a function called calculate duration and use the date diff to calculate the duration of each shopping session in minutes. And then we use auto table to add this new column and select the query to show the results. In the output, we can see the duration column have been added successfully. We also did some housekeeping too. With this duration column, we can understand the customer behavior better in terms of how long they are engaged in a shopping session. Next. The second column we added is the total amount in the cost table. Similarly, we created a function to calculate the total amount in each shopping cart and then added it to the cart table. And as you can see in the results, there is a new column in the cart table showing the total amount in each cart. And we also have two table level check constraints in our database. One is to check the product table to ensure the price needs to be greater than 0 and the stock quantity cannot be negative. We built a US check price function, which returns a Boolean value to check the rule. And we add the table level constraint check to the product table by using auto table. To verify it does work, we insert some testing data to the product table. If the price and the stock quantity are both positive, the data can be inserted successfully. But if the price or the stock quantity is negative, there will be an error. And another table level constraint is to check if shipment date is valid. A valid shipment date should after the order date. So we wrote a function to compare these two dates and add a constraint check into the shipment table. There are also some testing data. We can see for the order date at August 1st, the shipment date at August 2nd can be updated successfully, but at the July 31st, we'll make a mistake. We also have created 4 views for the purpose of user reports. The first one is customer order status view. The view created by drawing 3 tables, customer orders and payment. It can provide a comprehensive summary of the customer's order and the payment status. The second is product review summary. We join the product table with review table and use AVG and count function to get the average rating and the quantity of the reviews for each product. So this view is very useful for us to analyze the customer feedback on different products. And then we have cart details view to show what product quantity, price, and the total amount included in each cart. With this view, it's more clearly for us to get the aggregated information of the cart. And at last, we have shopping session duration view. We calculate average shopping session duration for each customer in this view, and it can provide some valuable insights for analyzing customer behavior. And then I will pass it to my teammate Yuehan to introduce visualization part.
Thank you. To make informed business decisions, we decide to use Tableau to do some visualizations here. For example, this is a kind of called data overview of the visualizations. It contains the basic information of the customer, and it can comparing to the data it just stored in the database is it's better for the customer or the user to have a brief understanding or the brief overview of the whole data structure. And another kind of visualization is geographical distribution of visualizations. For example, here is we collect some customer information which have geographical locations located in the United States, and it must show in the map to have some further understanding of location distribution. And another types of visualization is used for statistical analysis. For example, here is we have the ratings Here we have a rating for 3.9, which has 30 total reviews. It shows some deep insights on the data. Thank you. Is there any questions? Is there any questions?
Hi, Team 6. Thank you for your presentation. I have a quick question though. In the shipment table, we have you have attribute as tracking number. So can it be further modified, like based on the tracking number, you can actually get the status whether your package or delivery is out for like package is out for delivery, or maybe will reach to you within 2-3 days, like that, under tracking number, like with respect to tracking number.
Yes, here you can see we have
Shipment.
shipment. Here you can see we have a one-to-many relationship between order and shipment. So each order will be separated if we have more than one items. So each package will have a tracking number. So that's why we set up like this. So I mean, each all the shipments, all the tracking will be tracked.
Okay, got it. Thank you.
You can find everything is on. Yeah, thank you. Is there any more questions?
I would like to ask one question. So it's not particularly from your implementation, but I would like to know that what other improvements can be made to the existing implementations that you have?
Improvement to me, right? There's many just I can't say drawbacks, but something to be improved. For example, we don't add too much data points here, or maybe if it's better, we can add more than 100 data points, but we just have tens of data, so it's not very clear for the visualization to show kind of a trend or some of deep understanding. So more data points is first step, and I think we can also make some improvements in our like table level checks, constraints, or views or some computer columns, such kind of things. We do not make many attempts on this kind of ones, but we can see if we have any more points we can find out in our database, something more valuable.
Makes sense. Thank you.
Yeah, thank you.
Great work and the presentation from Team 6. Great question. Thank you all. This is the end of our project presentation. I was impressed with your accomplishments in DAMG 6210. Kudos to everyone.